All right, today's lesson is going to be about a process we call dimensional analysis. Now, the idea behind the process is that it's going to let us get from one unit to another, but instead of having like a full equation for every single thing we do, we're just going to use the dimensions, which is essentially the same thing as units. Okay. The word dimensions in our case means the units that are on the number. So we're going to use those, okay, to analyze our number, to change our units from one thing to another. Okay, well, the first thing we need are a series of equalities, which are just simple math facts that most of which you either have known before, or I will give you a long list of a variety of things that you might not know. So things like we know that 1 foot is equal to 12 inches. You may or may not know that 3 teaspoons is equal to 1 tablespoon. We can use it to convert between English units like 1 inch into things like centimeters. We can also say things like there's 100 centimeters in 1 meter, or we can talk about how temporary things. So like if I have an ammonia molecule, 1 NH3 molecule is going to contain 3 hydrogen atoms. All right, now, NH3 is not always, we're not always comparing it to the hydrogen atoms, but 1 NH3 molecule will always have those 3 hydrogen atoms. Okay, so those are, again, equalities is simply one thing is equal to another thing. Okay, our second step are called conversion factors. These are fractions made from equalities. Okay, and what that means is we're going to take these facts and just turn them into fractions. Now, that can mean that there's 1 foot divided by 12 inches, or I could say 12 inches divided by 1 foot. Well, no matter how I write any of these, it stands that these two things were indeed equal to one another. And we know from math that if you take two things that are equal to one another, say like 5 plus 2 divided by 7, well, 5 plus 2 is equal to 7. Okay, if we simplify this, you get 1. And that happens absolutely every time. If I take 1 foot and I divide it by 12 inches, or if I take 12 inches and divide it by 1 foot, I get 1, which means that I can multiply by these fractions and it won't do anything to my number, because if I then multiply by 1, it doesn't change what my original value is. Okay, so to do the dimensional analysis, what we do is we will be given a number in a question, and I didn't put a question here. I have some examples here in a second. Okay, you start by drawing this big long line across your paper. Sometimes it needs to be this long, sometimes it needs to be shorter, but I find it's easiest just to draw it really long, and then we'll be happy. Okay, this line right here is a fraction bar, and I know we don't like that word, but relax. We're not actually doing anything with fractions. Bar. Okay? It's going to represent one big long division problem, and then we're going to plug these fractions in so that this bar lands where this line is. Okay, we're going to move that down here. So let's say I want to know how many inches are in 13.7 feet. Now, I know you can do this without using this process, feet to inches, but what we're going to see is sometimes we make mistakes. Sometimes we multiply when we're supposed to divide. Also, I'm going to start you off simple. Keep in mind that when I do this, I start you off simple, and I have a reason for doing this and teaching you the process so that when I put in new things that actually you'll see apply to chemistry a little bit better, you're not as lost. So we're going to start talking about familiar things. Okay, then we draw a little happy face under here, mostly because nothing else goes under there and it bothers kids, and the happy face makes us feel better about the process. Okay, we're going to draw a bar right there. This right here, I've had kids refer to as a multiplication bar because this is a division bar, so this one's a multiplication bar. Okay, multiplication bar is not really a thing. Really what this is it's a parenthesis. It's just a line is all it is that separates this from the rest of the stuff we have to put in, so I don't have to write it as separate fractions, because otherwise it looks like we're multiplying fractions together, and nobody wants to do that. This way, it's actually going to look a little bit more condensed and easier to cope with. Okay, so I've got my 13.7 feet right here, okay, on my long fraction bar, and I've drawn my multiplication bar in there to represent that, okay, I'm going to move on. Now you choose a conversion factor. Okay. That has this unit that I want to get rid of, right? I want to remove feet from the system. So in order to remove something that's up here on the top of a division bar, I'm going to put it on the bottom. So I want a conversion factor that has feet down there, so that when I take feet divided by feet, they're going to cancel out, okay? And something that it's equal to and is useful to me on the top, okay? So here, we'll see that this conversion factor has feet on the bottom, right? So we're going to take this and we're going to plug it in right there. And we're going to say 12 inches is equal to 1 foot, okay? The best thing you can do for yourself is draw your line, draw your multiplication bar, give me the first number, the one that's in the question, the number that you're given right here, and then remember that whatever's here goes here. This number, this unit, not number, this unit will always drop straight down there, okay? And we will dance in class, okay? If you want, I will show you the happy, whatever's here goes here dance, okay? And then you find something equal to it that's useful to our process and put it up here. Okay, now the feet will cancel with feet. I no longer have feet in this process. I only have inches. So to solve, and I was after inches, that's what I was trying to solve for. Okay, so I'm going to find an answer. Now, what we do is we multiply by anything that's on the top of this division bar. Okay, and then I'm going to divide by anything that's on the bottom of that division bar. All right. So I would take 13.7, okay, the 12 is on the top, times 12, divide by 1. I'm not going to put that in a calculator because I'm smarter than that. Okay, equals, and I get 164.4, okay, inches. Now, it is absolutely vital. I know I've preached this all year, but it's been a while since we worked with math. It is absolutely vital to this process that you put units on things. You have to put every unit on every number ever, or the process just doesn't make any sense. Okay? All right, let's do this again. Okay, so our first extra example, how many teaspoons are in 1.5 tablespoons? You might actually want to do this someday. Recipe calls for 1.5 tablespoons, and you don't want to get you don't have a 0.5 tablespoon somewhere. So how many teaspoons can I use? Okay, so again, we're going to draw a nice long line. And I know I'm starting with 1.5. We're going to abbreviate that. Tablespoon. Okay, draw a line. Happy face. Okay, I know I'm going to put tablespoons down here. Okay, I need an equality for this. Now, if you look at the list of equalities I gave you, you will see that 1 tablespoon is equal to 3 teaspoons. Okay, so I can go directly from teaspoons to tablespoons. 1 tablespoon, 3 teaspoons. Again, they're both on the top. So I multiply all the numbers by anything on the top. 1.5 times 3 is on the top, 1 on the bottom, so I don't need that. That's 4.5. Not so bad, right? Okay. How about this one? How many yards are in 1.2 miles? Well, on your list, you'll see that 1 mile equals 5,280 feet, and that 1 yard is equal to 3 feet. But I don't have an equality that relates directly between miles and yards. But never fear. We're going to start exactly the same with our 1.2 miles and our happy face. Okay? And I take whatever's here, goes here. So I'm going to write miles there, and I can relate miles to feet. And I know 1 mile equals 5,280 feet. But that doesn't get me where I need to, right? That cancels my miles and it gives me feet, but I was asked for yards. So all I need to do is draw another division or multiplication bar. Okay, and we're just going to keep going along this line. That's why we made it so long. Okay, I have feet here. We're going to drop them down. Still the same thing holds. Whatever's here goes here. And we put something useful up here. So go with yards. I know from here that 1 yard equals 3 feet. You'll notice that I'm not just always going to put the 1 on the bottom, right? I put the relationship however it works. Okay, 1 yard equals 3 feet. So I can put the 1 yard on top and the 3 feet on the bottom so that I can cancel 1 foot on the top, 1 on the bottom. They'll cancel out. Okay? So I go to calculate and it says 1.2. Okay. The 5,280 is on the top. Okay. Divided by 1, but we're not putting that in the calculator. Times 1, also not putting that in. Divided by 3. Okay. And we will get 2,112 yards. Not so bad, right? Last one. Okay. How many hydrogen atoms are in 9 dozen water molecules? Okay. Well, I know that water is H2O. Okay. So 1 molecule, H2O, I can see has 2 hydrogen atoms. But I'm asked about dozens, right? Well, I know that 1 dozen is equal to 12 things. Okay. So I can put anything I want in that things spot, right? So we'll draw our line here and we'll say 9 dozen molecules. H2O. Okay. Happy faces. We're going to get rid of the dozen first. So I'm going to come down here, right? 1 dozen. It's going to go on the bottom. Molecules. H2O is equal to 12 molecules of water. Okay? Well, but that's not what I'm asked for, right? I'm asked for hydrogen atoms. So I draw another line, and I take this right here, drop it to the bottom, molecules of H2O, okay. Atoms of hydrogen, and I know 1 molecule will give me 2 atoms. And I didn't mean to make almost all of these multiplication, it's just a coincidence. Let's scoot them up. We can get our calculator in here a little bit. Okay, so I take 9 times 12, okay, divided by 1, times 2, divided by 1, will give us 216 atoms of H. Okay? And that's all there is to it. You just kind of have to find the puzzle, the way through your equalities to get from where you started to where you want to be. Okay, good luck.